Welcome, my name is Gabriel and I'm a co-developer of the REI3 application platform. Today we're going to take a look at backend functions and trigger. This topic is a bit more complex. This is for people who want to take their applications to the next level. So if you never worked with REI3 before, or if you're just starting out, I would suggest you look at our other videos first. For everybody caught up, let's jump right into it. So let's begin by quickly explaining what a backend function actually is. As with any other application, a function in REI3 is a piece of code that an application author has defined, which can then be used and reused in different contexts. The special thing in REI3 is that we have a separation between backend functions and front-end functions. A backend function is a piece of code that is executed on the backend, which means on the server side, or more specifically on the REI3 database server. A front-end function is executed on the front end, which means on the client, or more specifically, inside your browser. So on your phone or desktop PC, it would be executed in Chrome, Safari, or Firefox. Front-end functions are a topic for another day, so let's get back to our backend functions. So when would you actually use backend functions and what are they good for? The basic idea is that backend functions do all the things that a system should do on the backend. So for example, if data changes inside your system, then there could be a backend function that checks the change, create an audit log, or override it based on business rules. And here we're talking later about triggers, so something to look forward to. Another thing that you can do is limit access to individual records via REI3's relation access policies. You can also use functions to talk to the REI3 system, to send emails or execute REST calls. And lastly, you can run your function in a scheduler or in multiple schedulers to execute things regularly, like generate data, send notifications if something happened, or maybe if something didn't happen that should have happened. But enough with the try theory, let's look at how backend functions work in REI3 directly. So here I have a prepared system. This is a portable version of REI3 with a couple of applications installed as reference for later. Let's go into the builder. And then I have an empty app down here. And if we go into functions back, here we have all our backend functions, which are currently none. To create a backend function, it's as simple as clicking on New and choosing a function name. These additional options down here, we're going to take a look at a little bit later. Let's just create a function for now and jump into the function editor. Looking at the function editor, on the left side we have our function code. This is what the function actually does when we call it. And on the right side we have a couple of tabs and options that are related to this function. Starting with the properties, we have the function name. This is the name that we've chosen before, and this is the reference inside the builder. So this is how you can see what function is what. And if you want to further explain what your function does, you can use title and description fields to go into more detail. Moving on, we have our arguments. This is what the function uses as input. So if you want to execute a function that does some calculations, usually this function needs some data to work on, and this is what arguments are for. And then we have our function return, which is a value that the function at the very end returns so that you can see what the result is. Then we have the front end call. This is something connected to front end functions. And this is something we're going to take a look at in the future front end function video. Lastly, we have schedules, and we're going to take a look at that at the very end. So now that we've taken a look at the different options that our function has, let's start actually writing one. So on the left side, again, we have our function body, and this is a particular language. Here we're talking about PL/SQL for Postgres. This language is a programming language for the underlying database system, and REI3 always runs on Postgres. So if you want to really learn that language, you can always Google for PL/SQL for Postgres, and then you'll find lots of tutorials. But very shortly, in PL/SQL, you have your declare block at the top, and here we can declare variables. Something like num1 is an integer, and num2 is also an integer. And then inside our function block, this is begin to end, we can actually do something with our variables. So we can say num1 plus num2. But right now, num1 and num2 don't have a value, so we would have to assign that. So we could say num1 equals 12 and num2 equals 45, for example. And as you can see here, this is how you assign values in PL SQL. So going from the top, we have two variables, num1 and num2. We assign both a value, and now we return the sum of both variables. And on the right side, we have a tab called execute, and here we can live execute our function. We can click on execute, and now we get to return 57, which makes sense. But most of the time, you don't declare your variables inside your function, but instead you take them as arguments. Quite often, you want to call a function, you want to do some calculation with it. So what we can do here is we can define our variables as arguments. So num1 is an integer, and num2 is also an integer. And so we don't need them in our function body anymore. We can just remove that. Then we can save. And now if we go back to execute, now we have two inputs available, num1 and num2. So here we can type in any value that we want, doesn't matter, and we get the correct result. So now that we've looked at this very simple example, I'm going to show a couple more examples of what you would practically do with backend functions. Just be aware what I'm going to show now is a bit more complex and complicated, and I'm not going to explain every single line to you because this is out of the scope of this video. Just to give you an idea what you can build with these backend functions. So let's start with our projects app that we have in the same system. Here we have a couple of backend functions already, and here we have a function for calculating date durations, for example. So we do calculations on Unix time, we have an if statement that ends down here, and we have a while loop that goes unless this value is larger than the other value. So you can do if statements, so you can do control flows, you can do loops, so you can iterate over arrays or iterate through values and so on and so forth. Next, in our Absence Manager application, we have a function that replaces text within templates. So right here we have an input variable, as you can see in the arguments, and the input value within it, we have a placeholder, and this is replaced by another text value. In this case, it comes from another function. So right here we have an example of you have a template, you want to replace some text in it, and this is how you could possibly do it. Another example is in the application tickets, where we have a function that sends an email. And as you can see here, this is a larger function. There's lots of logic in it, and we have lots of variables on top. And besides stuff that we've already seen, like an if statement, for example, we have things like select statements or insert statements. So this is what we call SQL, or structured query language. And the nice thing is that in PL SQL, we can directly talk to the database. We don't need to connect to anything. We can directly execute SQL statements to read data, create data, change data, or delete data. So let's take a look at how that works. Let's go back to our own application. And in order to actually work with the database must have some structures already there. So when I talk about structures, what I mean is stuff like relations. So right now this is an empty application, so nothing is there. So let's just create a relation. So what we could do, for example, is we could create a relation called books, for example. And in our relation books, we have two attributes. We have the book title, which is a text value, and we have year of publishing, for example. And this might be a whole number, like the date. And now that we have our relation books, now we can go in any function in our backend, and now we can work with that. And now we look at something we haven't looked at before. This is what we call placeholders. So placeholders help us work with the database in a safe way. What do I mean? So when you are in your function, you could at any time go in and do something like this. Insert into my app.books. And then we would have our names of our attributes, which would be the title of the book and the year of publishing. And then we would have values, something like my first book, exclamation mark, and the year is 2023, for example. And this would be valid SQL. We could execute this, and this book would actually be entered into the database. We would have this entry here in books. The problem is that, well, this is just text. If we change the name of books, if we change the name of the relation, this wouldn't change here. So demonstrate, we have my app books, this is my relation. And if I say it's not called books anymore, but books2, for example, and we go back into our function, it hasn't changed. It still says books. And this is where placeholders come in. So instead of typing it myself, I could do insert into, and then I go into placeholders up here. And here we have placeholders for different entities, and we'll start with relations. So relation, then we see our relation called books2. We've renamed it. We click on this little radio icon, and now we can just insert it like that. And then for each attribute, we can open books2, select the appropriate attribute, type it into here, comma, and the next attribute. And then we can just do values, and we can copy paste this. And this would be valid code as well. And the benefit is that this is a placeholder, which means that if we change anything, this will change as well. To demonstrate, we'll save our function. And now we go into our relation and we rename it again from book2 to just books. Save, go back to our function. And now it says books instead of books2. And you have up here this little preview button. This actually resolves the placeholder so you can easily see what you're actually talking about. So the idea is that when you work with SQL, when you want to create data or delete data, insert data and stuff like that, you'll use placeholders. And if you have larger applications, like if we go into another application, we go into any of our functions, now you can see you have access to all of your relations. And so you can create select statements, insert statements, and so on very, very quickly in a safe and secure way. So going back, now this is a nice example, but it's not actually interesting unless we actually execute this. So let's remove our old example here. We just say return 0. So this function should insert a line of data into my books relation. So let's see if it actually does that. Save. And then we'll execute. Well, we have two numbers as arguments. We don't need those either, so let's remove them. This function doesn't take any attributes right now. So we go in, we execute it, we have response 0. That's nice. And now if we go into the relation books, we can go into data view, and as you can see, my first book 2023. And as we've learned before, we can always just add arguments. So we could add the title as an argument, for example, text, and then we would have the year of the book as an integer, for example. And now instead of fixed values, we could just use our arguments here. And so the nice thing now is that we can go into the execute, and we could say my second book, and the year is 2024, for example. We execute, and if you go into the relation, books, data view, now we have 2 books created. And you can execute this however you like. You can put it in a loop. You can create thousands of data sets at any time just by executing your backend function. Besides inserting data, we can also get data or load data from a database. And for this example, I'll create a function to count the number of books in my system right now. So I'll create a function called count books. And within my new function, I'll create a select statement. Select count from relation books. And this select would give me all the number of records in my relation books. In order to output it, I could put it in a variable. So I could say count of books, for example, it's an integer. And if I say select count into, I can place the result from select count into a variable. And this variable I can use as a return. So when I execute my function, I get a number of books in my system, currently 2. And so next to selecting data, inserting data, you can also delete and update data. As long as you use placeholders, you won't break anything. And if somebody, or if you yourself attempt to delete a relation or an attribute, and you're still referencing that relation or attribute inside one of your backend functions, the system will block the deletion and protect your application from getting broken. Next, we're going to take a look at the other kinds of placeholders that we have available. So the next type would be the function backend placeholder. So as you can see here we have the same functions that we already created in our short tutorial so far. So we have our count books and we have our myfunc. So the idea is that you call a function within another function that you have. And why would you do that? Well, first of all, you can repeat things. So you can write helper functions to do calculations, to do things that you regularly need. Or you could do stuff like generate data. And to demonstrate, let's take our myfunc, the first function that we've created. And the last thing we did with it was to create a books record every time we call it. As you can see here, insert into my books, and now we create a new book record. For this example, let's rename this function from myfunc to something that actually describes what this function does. In this case, create book. And now we could create a third function called generate books, for example. And within generate books, we can use the placeholders to call our create book function multiple times. So we can go in and say create book once, and then we add some data like my third book 2024, and then we'll copy that to my fourth book 2025, for example. And just to note, if you do a function call, you always have to do something with return value. So you could either ignore it. We could say perform. This is the command to just execute a function and do not care about the return value. Or we could assign the return value to a variable. So we could say return value integer. And then we could assign the return value of a function call to a variable and do something with it. But in this particular case, we don't care. We just want to generate books, so we can do a perform. And now when we execute generate books, we would call our create book function from before 2 times and generate 2 books. So just to demonstrate, we'll save that. We go into execute, we execute. And now if we go into a relation, books, into our data view, we have 4 records. So this is why you would use these function placeholders so that you can actually call other functions. And if you use loops, if you iterate over counters, for example, you can generate thousands and thousands of data sets with 2 or 3 lines of code. Besides directly calling functions, you can also use functions or their return values as input. So if you do like SQL, for example, select count from something, doesn't really matter for this example. You could say where, in this case maybe the book title, equals, and then we could do a function call. In this case it doesn't really make sense because we get a count of book, but this function could return a book title, for example, and then we could filter with the return of this function call. So you can use functions basically anywhere within your backend functions. You can use them as input, you can use them to filter with, you can just execute them to generate data as we've seen before. So very, very powerful. And if you have a number of helper functions, again, looking at other applications, you can see how many of those are usually used in large applications, not only to generate data, but also to send emails and stuff like that. The last type of placeholders are the instance functions. So instead of calling functions that you yourself have created, you can call functions from the REI3 system itself. So whenever you need to know something about the currently logged in user, whenever you want to tell the system to do something, you can use instance functions. So for example, get login ID gives us the ID of the user that is currently logged in and accessing the system. So if somebody clicks a button, if somebody stores something and a function of yours is being triggered, is being started, then a login ID would reflect the current user. Same with the language code, which is the language code that the current user has selected. Is it an English language code, Chinese, German, whatever? You can call log functions to write to the system log if your function is very complicated and runs into trouble, you can log a current value, for example, into the system. Or you can send emails. And whatever you do, you always have this context menu help, and this tells you exactly how you would call this function and what kind of values it expects. So for example, mail send is a rather large function. We have smaller ones as well, like the get login ID doesn't have any arguments. It just gives you an integer value, which is the login ID. But going back to the mail send, even very large functions with a lot of arguments don't need all of them necessarily. You can see we have default values here. So in this particular case, if you want to generate an email, well, we can just go into any function. Then we select mail send as a placeholder. Then we say perform, because we don't care about return value. We just want to send an email. And then we need a subject, hello there, a mail body, my test mail, and a recipient, friend@hotmail.com, for example. And this is all it takes to generate an email in REI3. And these values you could take from arguments, you could select them from a relation, so you could generate emails on any form if you like. And you have lots more options, but not all of them are required to actually send an email. But you could, for example, add CC, recipients BCC. You could select which account name this email is being sent from, or you could attach attachments. You could add files to your email. And most of our context helps also have some explanation on how these arguments actually are interpreted. So if you need any help, just go into the context help, and then you'll see how you would actually do these calls. So whenever you need to talk to REI3 itself, the REI3 server, you can execute these instance functions. And sometimes these instance functions are not even enough, because sometimes you want to do something very complicated. And for this, we have something called function templates. So something we skipped over at the very beginning is when you create a new function, you have the option to select a function template. And one thing that can be a bit tricky is how to parse or process incoming emails. So sending emails is simple enough. We have a recipient, subject, body, and out it goes. But what happens if an email comes in? Because an email can be very complicated. So we have a function template called email processing incoming. And then we can create a new function called mail incoming, for example. And here we have a lot of code that is just example code, how you would process an incoming email, with lots of remarks and comments, how the code actually works, what it does, and how you would handle this. If you removed all these comments, then this function would be like 15 lines, basically. But we take a lot of time and care to make sure that everything is explained so that our templates are as useful as they can be. And there are other templates as well. So for example, you want to do REST calls. REST calls can be a bit tricky because every REST interface can be different. You have different headers, different protocols, and so on. And so we have a couple of templates to help you get started. The thing that we skipped over before is how your functions can actually be executed regularly. So up until this point, we've used the execute option here to directly start functions from inside the builder. And we also used our perform and our function placeholders to start our function within another function. But sometimes you want your functions to be executed regularly. So if you take a look at the example mail incoming, this is a case where we want to pass emails, and it would make sense that we would pass emails every couple of minutes because, well, we could get an email every couple of minutes. And for this, we can go into the function properties, and down here we have our schedules. So in order to regularly execute a function, you just add a schedule, and then you select how often it should run. You could say every 10 minutes, for example. Or you could say, for something that doesn't happen as often, every couple of weeks, on Friday or on Tuesday, whatever, at 12 o'clock at noon, for example. But in this particular case, it would make sense to run it every 10 minutes. After saving your schedule, we can look into the admin panel. We can go to the scheduler. And down here, we have all the tasks, all the functions that are being executed regularly. And down here, we have our My App and mail incoming every 10 minutes. There's also the use case where you want to run a function exactly once. So for example, you have a function that should do a cleanup operation after an application has been updated. And for this, we have another scheduler type. So let's go into another function. And this type is called once. And when you select a once scheduler, then this function will be executed exactly once the next time this application, well, boots up or is updated. So if you have a script, a function that runs a single time because it must migrate some data, you can select a once schedule and it will be executed exactly once. Another way of how a function can be called is by a so-called trigger. And this is one of my favorite topics and the last one we're going to take a look at today. So a trigger function is something that is called every time something inside your database changes. And you would set your triggers on a particular relation. So we go into our relations, then we go into books, and down here we have the trigger options. And triggers have different settings, have different options, and we're going to take a look at each of these in a sec. But first of all, you can select a function that this trigger would execute. And right now we can't select anything because we haven't prepared a function yet. So to actually create a trigger, we have to go into our backend functions and create a new function. To be usable as a trigger function, it first needs to be of the type trigger, because trigger functions work a little bit differently, and we'll see how exactly in a second. And second, we'll just need a name, and what we usually do is we use another prefix, in this case trg, so that we can see quickly that we are talking about a trigger function. And then I'll just name it books, because this is a trigger for the relation books. So once it's created, we can click on the form or the function editor again, and now we have a trigger function. As you can see, it's a bit different than regular functions. We have a different return code. Instead of 0, we have return new. This is very special. And if we go into the properties, we can also see that we don't have arguments anymore. And even the return code cannot be changed by us. It always must return trigger. Because trigger is actually quite special, it is something that the database executes automatically and it expects a trigger return every time. And as you can see, there's also no execute option because a trigger needs a data set to be changed, updated, created, deleted in order to actually fire. So how does a trigger actually work? First of all, a trigger function can basically do anything a regular function can do. So you can go into your code body, you can add your code here, and then you can do what you did before. You can talk to relations via select, insert, and update if you want. We can call other functions, and we can also use instance functions. So you can have a trigger on a relation, and if you create a new data set, we could send an email, for example. So triggers in this case are very similar to a regular function. But now the fun part. When you have specific trigger types, we can do things directly to the datasets. So the normal use case is we have a so-called before trigger. Going back to the relation, to books, then to triggers, here we have the before trigger. And we'll look at after trigger a little bit later. But the before trigger is the most simple case. We have a before trigger, before insert, so before a dataset is being created, we execute a function, and now we already have a function prepared, so we execute trigger books. And the before function is actually the easiest case. So going back into our function, trigger books, and what we can do now is we can use the new keyword, this one, to directly work with the data that is being inserted. So again, we're talking about relation books. So in our relation books, we have our attributes, title, and year of publishing. And what we can do now is we can directly access these. And we don't even need select, because in a before trigger, you can just work with the data directly. What we can do is something like this. New dot placeholder title equals test. And this would overwrite the value in the attribute title with the value test exclamation mark. So every book that we create now, its title would be overwritten. And we can do the same thing with every single attribute that we have. New dot year of publishing. Oops, that was wrong. Here we go. And now the year of publishing would always be 1999. And this is how a trigger can directly work with the data being updated. But of course, this is not very useful. These are fixed values. We could do much more interesting things. We can do calculations, we can call other functions, and then we can do checks and apply business rules. So for example, we could say that if the year of publishing is before 2000, then something would change in the title. If it's after 2000, it wouldn't, and so on and so forth. And to make it a bit easier to work, we have these options here with the new prefix and the old prefix. Old is something we're going to take a look at a bit later. And so instead of just typing new dot, we could use the new prefix up here and then select a placeholder, click here, and now it's automatically there. So we save a couple of clicks. It's quite cute. But the most important thing is that in a before trigger, you always need to return new. Because if you don't, then the data being inserted is being lost. This new here represents your data set. So you have your relation books, and we are adding a title, we're adding a year of publishing, a date of publishing, and if you don't return new, if you return 0 or something else, either the trigger will fail or your data will not be inserted. This is definitely not fun. So before trigger is very useful because now you can directly manipulate your data before it's being inserted. And the same thing, when we go back to the trigger, we can do for updates. If we go into the trigger, we can also enable it for updating, which means it will also execute your function every time data is being changed. And it works the same way. We have our new, and every time we would change the title, it would be overwritten. And every time we change the publishing, it would also be overwritten. Then we also have the delete option. And now it is a bit tricky because delete works with a different placeholder. Instead of new, we have the so-called old. Because if you delete something, you don't have a new record, you have an old record that is being deleted. So for example, if I want to access the title of the old record being deleted, I have this old entity here. And if you're on an if you're on a delete trigger, you have to return old instead of new. And that's a bit tricky. So what you can do is either you create two trigger functions, one for deletion and one for inserts and updates, or you use a if statement. You can say if tgop, this is the name of the operation of the trigger. You can say insert, then return new, and we can copy paste this here. So only if it's an insert, we will overwrite the title and the year of publishing. And if, and the else case, so this is if we are not on insert, if we are on delete, then we have our old value here. And what we could do is, I don't know, create an audit entry or send an email, for example. But most importantly, we have to return old, because if we don't, our entity wouldn't be deleted. So if we have a delete trigger and we execute this function trigger books, we have to return old on a delete trigger, otherwise it wouldn't actually be deleted. This is a little bit of the special cases that we have with the trigger. You just have to keep in mind every time we're talking about an insert or an update, you're working with new and you have to return new. And every time you're working with a deletion, you have to work with old. To keep it simple, what we often do is we, again, just separate these two. You can just say trigger books insert update, for example. Then we remove the old case here. We just work with the new. And then we create another function called trigger books delete. Trigger function, of course. And then we can work with old. And we need to return old, very important. So going back into the relation, if we go that route, we'll just go in and say like, okay, our insert update trigger is only for insert update, not for delete. And then we'll create another trigger for delete specifically. So now depending on whether it's a delete action or event or an insert update action or event, we will be calling different triggers. Another thing that you can do, and this is something that a lot of people don't seem to realize, is you can just use these values as any other variable. So you can do stuff like insert into another relation. I don't have one here, so I'll just type something. And then you can use a value from your triggered relation to fill another relation. So you can log, for example. So these are just values. You can do whatever you want with them. So this is why triggers are very, very useful. Every time you create a data set, you can create another data set in another relation. Very useful for auditing or very useful to create child entities, for example. And the same with deletion. Every time you delete something, you want something else to be deleted as well to clean up, for example, or to fill an audit log again. So to reiterate, we've looked at how trigger functions are being called. So when you insert data, when you update or delete data, then trigger functions are called depending on your settings on the relation. But besides the before trigger, there's also the after trigger. So what is the point for the after trigger? The idea is that you might have changes or might want to manipulate something or log something before it's being written to the database. This is what the before trigger is for. And then you might have changes that you want to do after it has been written to the database. This is usually done if you want to clean up or if you want to create records that need to reference each other. So as an example, if we go back into our regular before trigger, here we have our new book with our title and we overwrite a couple of values. That's cute. But at this point where this trigger is being fired, the data set, the record, is not in the database yet. So if you want to create a log entry, for example, we could say a book has been created, yes, but we don't even know the ID of the book that has been created because it doesn't exist yet. It hasn't been written to the database. If you want to make sure that we can reference this record later, if you want to look at relationships and we want to reference different records to each other, then we need to know that they have been written to the database so that we can do lookups. So for example, right now we could do a select, but if we do a select of all books that we have in the system like we did before, select count from books in this case, this count would not include the book that we've just added because right now, right at this trigger has fired, at this point, the book hasn't been added yet. So for this, we have the after trigger. And to demonstrate, we'll create a new trigger function, trigger books insert, for example. We'll say it's a trigger, of course. And in an after trigger, well, let's just call it after just to separate those cleanly. In an after trigger, we can still work with new, that is perfectly valid, but what we can't do is we can't use the new keyword to override anything. We can't do this. This is something we could do in a before trigger, but the after trigger is already written to the database. So this change would not actually do anything. But what we can do, however, at this point is we can do this. And it would return the right value. It would tell us how many records would actually be in the relation books because it has been written to it. It's an after trigger. And this is especially important if we want to do something like auditing. If you want to say insert into audit log, again, we don't have this relation at the moment, so I'll just put something here. And then we could say values new dot ID. This is the ID of the book record that has been created. This now exists because the book record actually has been created. This is what the after trigger is for. It waits till a change to the database occurred, and then we can do something with the values. We cannot overwrite them, but we can insert something, we can call another function, we can do whatever we like, except overwriting the original record. So that is what the after trigger is for. Usually it's done for logging. Sometimes it's used to create child records after the parent has been created. Because without the parent being written to the database, well, we don't have an ID that we can reference. It doesn't exist yet. For this trigger to actually fire, we would still have to register it at the relation level. So we go back to relations, then to our books, then we have our triggers. And here we would have to select after trigger, after insert, and then execute our insert after trigger. As you can see here with the naming, it's very important to name your functions wisely so that you can easily see what function does what. So this is the after trigger. Lastly, we have a couple more options we can go into, but they are used very rarely. So for example, by default right now, every trigger that you have created or that we've created together has been executed for each row. That means that every time data is being inserted in the database, for each row, a trigger will fire individually. So if you insert a single record, it doesn't really matter, but if you insert multiple records at the same time, like you do a CSV import, or you do a bulk action, for example, then you would execute your trigger function every time for each record. But sometimes, rarely, but sometimes, you want your trigger to just execute once. So you have an import of hundreds of datasets, for example, and you don't want to execute the trigger function every single time for each record. So in this case, you can disable each row, then this trigger would run on a statement level. So if you have a statement of 100 records being inserted, again, like in a CSV import, then the trigger would only run a single time. Again, very seldom used, but it can be useful for things like an audit log that says, okay, you've executed a data import or you generated a couple of data sets, and this is a number that have been generated, for example. And lastly, there's a deferred option. This is actually something for specialists. The deferred option, just very shortly, is to wait with the execution of the trigger until all other changes to the database have been made. So this is especially important if you have a statement that includes multiple relations. Again, for specialists, but if you have that need, if you have a form where you join multiple relations via relationships and you create multiple relation records at the same time, then a deferred trigger waits till all the relation triggers have been dealt with before this particular trigger will fire. So a deferred trigger is very, very useful. It can only be done on an after trigger. And it's especially useful if you have, again, joint relations on the same form, for example, or if you do a complex SQL insert with multiple relations at the same time. It will wait till the end of the transaction, and then you have access to all the record IDs, all the data that has been inserted into the database. If you don't do defer, then your after trigger will immediately trigger, even if there are other changes to the database still being made. So this is the deferred option. Again, only interesting in rare cases, so I don't think most of you will actually need that. To close out on a couple of things to keep in mind when working with triggers. So we've created a couple of trigger functions, we've played around with a couple of use cases, but a couple of things that you can fall into that are quite nasty. So again, as said before, you always have to return the right type. For insert update, always a new. For delete triggers, always an old. It doesn't matter what changes you make. It must be an old or it must be a new, depending on the trigger type. There are other pitfalls. So for example, if we have a before trigger, we have a trigger that says, okay, before the insert happens, we want to overwrite the title. That's cute. Nobody's stopping you from doing something like this. And for those who have been paying attention, what we do here is we create a new data record in the relation books, which is the relation that also triggers this function. So what would happen is that once somebody anywhere creates a data set for books, this trigger would function, would overwrite two values, and then would also create a data set in books. This would cause an infinite loop, because every time the trigger is being fired because a new data set is being created, another data set is being created, which would call the trigger again, which would create another data set, which would call the trigger again. This is an infinite loop. And this case is obviously not very smart, but if you have multiple triggers that call each other, if you have different relations that are connected to each other, and you trigger one, you create your trigger functions, you have an insert statement, which could cause another trigger to fire, which could do another insert statement, which could trigger another function, you can very quickly go into infinite loops. So triggers are amazingly powerful, but you should be very careful by not to overuse them, because you can very easily run into situations where you create loops and then your application, well, it will not crash, but it will generate errors, and then you can't save your data anymore. Not very fun. And if you have a case like this, you would go into your application logs, and then you would find entries for infinite loop detected or something like that. And then your change wouldn't go through. So to summarize, today we've looked at backend functions in REI3. We've looked at how to create backend functions. We've looked at a couple of examples what you can do with them, mostly by looking at pre-existing applications. And just to note, you can always go into the repository of REI3 and delete any application as reference. And then you can look at them in the builder and see how they are doing things. So if you are interested in working with date values, doing calculations, you can install application for absence management or the time tracker, for example. Here we have lots of backend functions that do date calculations. If you want to do mail handling, you can look at our tickets applications. This one has lots of functions that are related to how to deal with email, for example, and so on and so forth. So we've learned how to create functions, what they are, what they can do. We've looked at how we can call these, that we can have our arguments in our regular functions, that we can have schedules that regularly execute functions, and so on and so forth. If you want to go much deeper into it, you can always Google just PL SQL for Postgres, and you'll find lots of tutorials. And REI3 doesn't do any magic, it just executes PL SQL functions. So as long as you follow those tutorials, they should work perfectly fine in REI3. If you want to do something directly with the system, again, we have our instance function placeholders, and these are the instance functions that the system offers. And over time, with more feature releases, more and more instance functions will pop up here so that you can do more and more things. Nobody's stopping you from installing other stuff on your Postgres system to enable more functions, but if you want to stay in standard, just work within REI3, use instance functions to talk to the system, send mails, do REST calls, and so on and so forth. And as long as you do it this way, and as long as you use the placeholders, it's very hard to break anything. Even if you try to rename stuff, if you want to delete stuff, your placeholders will protect you. So keep in mind, always use the placeholders. You can write pure SQL, you shouldn't. Just use the placeholders. Okay, that should be it for this not so short tutorial and video on backend functions and triggers. We will be taking a look at front-end functions in the future to talk about when they are useful and how they can interact with backend functions. So thank you very much for your patience with me. This has been a very long video, I know, and I hope to see you soon for the next one.